So one other way that we can solve for area when we have these tilted rectangles is the box method. So the way the box method works, we're not worried about perimeter. That's not going to help us here, but it does help us with area. So for the box method, the first thing I need to do is I need to draw the large box that goes around our shape. So we have a box that is essentially going to go all the way around our shape. And what we're essentially going to do is we're going to subtract all of these little rectangles that go around it, or the little triangles that go around it. So if I count from the bottom to the top of this box, we're going to have 12 units. And then the same thing from the left to the right, this is going to be 12 units. So our box area is going to be 12 times 12, which equals 144. That's the entirety of the box. Now, as we work around the box, we have triangle 1, which we'll call our red triangle. So we'll call this our red triangle. That's going to have side lengths of 6 and 6. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. So we're going to use our formula 1/2 base times height. 1/2 6 times 6. 6 times 6 equals 36 divided by 2, 18. And we're going to work our way around. Now this one is a little bit easy because we have a square, and so all of our sides 1, 2, 3, 4, 5, 6 are going to be 6 and 1, 2, 3, 4, 5, 6. So no matter what triangle we have, we're going to end up with the same thing. 6 times 6 divided by 2. So our orange triangle, 1/2, 6 times 6. And then our gray triangle is also going to be 1/2, 6 times 6. That's going to equal 18. And so to find the overall area, now that we've got our big box area, our area equals our big box, 144, and then we're just going to subtract each triangle area from the big box. And what we're left with is this area inside. So we take our 144, subtract 18, subtract 18, subtract 18, subtract 18, and we're left with 72 units squared, which should match the way we solved for it before. We can do the same thing over here. This one is a little bit different because we have not a square, but just a regular rectangle. So as we make our box that goes around, all we're trying to do is we're trying to create a box that includes these vertices, okay? But we can easily count 1, 2, 3, 4, 5 our way around the outside. 1, 2, 3, 4. Okay, so here 5 times 4 equals 20. The area of box number 1, our red box, we're going to go up 1, 2, 3, 4. We're going to go to the right 2. So we're going to have 1/2 times 2 times 4 equals, well, those 2's cancel out, so we're left with 4. Then we come out down here, we go down 1, we go right 2 for our dark blue box, purple box, whatever one it is. 1 over 2 times 1. Those 2's cancel out, so we left with 1. Our orange box, we've got 2 across, and then 1, 2, 3, 4 up. So again, we're going to be very much the same as our red box. 1 over 2 times 4 equals 4 because our 2's cancel out. And we can go ahead and show that for each one of these. And then for our gray box, we went up 1 over 2. So 1/2 times 2 times 1. 2's cancel out, so we're left with 1. And all we're going to do here is take our area. That's going to equal our large box. We're going to subtract all those little pieces, those little triangles, to get what's inside. So we subtract our 4, subtract 1, subtract 4, subtract 1, and we are left with 20 minus 4 minus 1 minus 4 minus 1. And we're left with 10 units squared as our area, which again should match our prior example. Just another way to solve for area. Doesn't really help us solve for perimeter, but it could be a little bit easier than using Pythagorean theorem to help us solve for area.